13.1, eighth one. A die is thrown 3 times. E is the event. 4 appears on the third toss. And F is the event. 6 and 5 appears respectively on first 2 tosses. We have to find the probability of E given F. So formula is probability of E intersection F. E intersection F divided by probability of F. That is the formula for probability of E given F. For that we want to find what is the event E, what is the event F, and what is the experiment here, random experiment. What is the experiment? A die is thrown 3 times. So that is the experiment, random experiment. So a die is thrown 3 times. So what is sample space? In the case of a die is thrown 2 times. This is a sample space. Sample space means set. So this is the sample space of the experiment. Die is thrown 2 times. Now when the die is thrown 3 times, the number of sample points or some number of elements in the sample space is 216. That is 6 raised to 3. If the die is thrown 2 times, then 6 raised to 2. Die is thrown 1 time, that is 6, like that. If the die is thrown 4 times, then 6 raised to 4. That is the number of sample points. So here die is thrown 3 times, so 6 raised to 3, 216 sample points are there. So it is not easy to write all the 216 elements. So we have to imagine, we have to think which are the 216 outcomes, possible outcomes. For that, to understand that, I wrote the sample space of the experiment. Die is thrown 2 times. So in this case, there are 36 sample points, 6 raised to 2, 6 raised to 2, 36 sample points. Here, now we want to know what is, no need to write the sample space because there are 216 elements are there. No need to write the sample space, but we have to write the events E and F. What is the event E? 4 appears on the third toss. 4 appears on the third toss. So we have to write the elements in which 4 appears on the third toss, right, as a set. So we have to write that E equal to, what is E? As a set. Now see here, these are the sample points in the case of the experiment. A die is thrown 2 times. So die is thrown 3 times means, see, when we consider each element in this, consider the element 1, 1. Consider only one element 1, 1. So what will be the elements corresponding to 1, 1? Starting with 1, 1. How many sample points will be there in this sample space, the required sample space? How many elements will be there? Starting with 1, 1. See, 1, 1. First element 1, second element 1. So next element represent the third toss because die is thrown 3 times. So this is first toss, second toss, third toss also will be there. So that is 1, 1, 1, 1, 1, 2, 1, etc. 1, 1, 6. So corresponding to this element 1, 1, the elements in this sample space is 1, 1, 1, 1, 1, 2, 1, 1, 3, like that, 1, 1, 6, till 1, 1, 6. 6 are there. Similarly, corresponding to each, corresponding to 1, 2, again there will be 6. 1, 2, 1, 1, 2, 2, 1, 2, 3, etc. up to 1, 2, 6. Similarly for 1, 3. 1, 3, 1, 1, 3, 2, etc. up to 1, 3, 6. Similarly 1, 4, etc. 1, 4, 6. Like that, for each of these 36 elements, there will be 6 elements more. So 36 into 6, like that we are getting the 216 sample points in this sample space. Now we should have an idea, then only we can write the event E. So event E is 4 appears on the third toss. So we can think about the elements 1, 1, 1, 1, 1, 2. In that set, how many will be there? 4 appears on the third toss. So 1, 1, 1, third toss means this one. Here 1, here 2, then 1, 1, 3, 1, 1, 4, 1, 1, 4. So only in that, the third toss, 4 appears on the third toss. See, 4 appears on the third toss. So in this set, 1, 1, starting with 1, 1, there will be only one element with 4 appears on the third toss. So similarly, in each set, 1, 2, 1, 1, 2, 2, etc., 1 will be there. That is 1, 2, 4. And starting with 1, 3, 1, 3, 4, only 1, 1, 3, 4. Then 1, 4, 4, 1, 5, 4, 1, 6, 4. Like that, in each there will be one element. So that we can write. So first set, if you consider no set by set, it will be easy to write. So we have to write the event E, that means 4 appears on the third toss. So E equal to 1, 1, 4. Then next, in this set only 1. In this set 1, 1, 2, 4. 1, 2, 4. Then here only 1. Then 1, 3. So similarly we can write 1, 3, 1, 3, 4, 1, 4, 4, 1, 5, 4, 1, 6, 4. No need to write all. We can write etc. up to 1, 6, 4. Like that we can write set by set. Etc. 1, 6, 4. Next we can consider this set. 2, 1, 4, 2, 2, 4, 2, 3, 4. Like that etc. we can write 2, 6, 4. Then 2, 1, 4, 2, 2, 4, etc. 2, 6, 4. Then next set 3, 1. 3, 1, 4, 3, 2, 4, etc. 3, 6, 4. Then similarly for etc. 4, 1, 4, etc. 4, 6, 4. Next 5, 1, 4, etc. 5, 6, 4. Then 6, 1, 4, etc. 6, 6, 4. Last 6, 6, then 4. So these are the elements in the even E. 4 appears on the third toss. So there will be 36 elements. 6 like that, 6 into 6, 36 elements are there. Now we want to write F. 6 and 5 appears respectively on the first and 2 tosses. So first and second tosses. First 2 tosses. That means first toss 6, second toss 5. So third toss can be any number. So which are the elements in F? F equal to, how we can write F? So F equal to 6 and 5 appears respectively on first 2 tosses. So first 6, second 5, all should be like this. So we consider only this set, 6, 5. So in that 6, 5, starting with 6, 5, there are 6 elements. 6, 5, 1, 6, 5, 2, like that, 6, 5, 6. 6 elements are there. So all that 6 we have to write because 6 and 5 appears respectively on first 2 tosses. Only that. See, remaining all not like that. Only that 6 elements are there. So 6, 5, 6, 5, 1, 6, 5, 2. So 6 and 5 appears respectively on first tosses, etc. 6, 5, 6. These are the 6 elements in F. Now we can write E intersection F. What is common element of E and F? Now this is F. Now what is, this is E, this is F. So what is E intersection F? Common elements. E intersection F. E intersection F equal to common elements. See 6, 5. Here in all these, the 4 appears on the third toss. In all these elements, 4 appears on the third toss. And in this set, there is only one element, 6, 5, 4. 4 appears on the third toss. Here there will be one element. In between, there is one element, 6, 5, 4. 6, 5, 4. So only that 6, 5, 4 will be the common element of E and F. So that is equal to E intersection F equal to 6, 5, 4. 6, 5, 4. Only one element, common. Now we can write the probability. Therefore, probability of E given F equal to probability of E intersection F. What is probability of E intersection F? Number of E intersection F. So in this E intersection F, there is only one element. So 1 divided by total number of sample points, that is 216 divided by, what is probability of F? Number of elements in F. What is the number of elements in F? There are 6 elements, starting with 6, 5. 6, 5, 1, 6, 5, 2, 6, 5, 3, like that, 6, 5, 6. If you write, you can write now. You write all the 6 elements. Only 6 are there, so you can write. So write that 6 elements. So in F, there are 6 elements, starting with 6, 5. 6 elements are there. So that is number of F, that is 6 divided by total number of elements in the sample space, 216. So 1 by 216 divided by 6 by 216, that is equal to 1 by 6. So the answer is equal to, therefore this answer equal to 1 by 6. 216 will be cancelled 1 by 6. So if you remember this, the sample elements of the sample space in the experiment where a die is thrown 2 times. Then relating to this, you can think about the experiment. Die is thrown 3 times. So imagine that. Then write order. So corresponding to each element, there is 6. 1, 1, 1, 1, 1, 2, etc. 1, 6. Like that, set wise, you can think and write the event E, then event F, then write E intersection F. Common elements, only one element. 4 appears on the third die and starting with 6 and 5. So only one element. So number of elements in E intersection F 1 divided by total number of sample points. That is the probability. Now probability of F is number of elements in F divided by total number of sample points. That is the probability. Here we want probability. This is also probability. So this is 1 by 216 by 6 by 216. So answer is 1 by 6. The same type 1 question is there in the example. Same type. Okay.